In this lesson, 22, we are going to focus on simplifying rational expressions. The official title is called equivalent rational expressions, and so that's what we're going to essentially do. We're going to start with example number 1, where it says consider the following rational expression. And so in this case, our first goal in this piece will be to find what's going to make a denominator undefined, right? For what values of a is the expression undefined? So just to remind you, to make a fraction undefined, then in that denominator, if the denominator is 0, then the fraction is undefined. So if we want to know what value of a makes this undefined, then the only thing we have to do is take that 6a minus 1 minus 3a, set it equal to 0, and then we can answer that question. So when we distribute, we get 6a minus 6, bring down the minus 3, equals 0. We're going to subtract these two, so we get 3a minus 6 equals 0. Add 6 to the other side, and we find out that a is equal to 2. What that means, if I put a into this denominator, I'm going to get a 0, which henceforth would make the fraction undefined. So what we don't want to ever allow happen in this fraction is we don't want a to equal 2, because that would make it undefined. So for the next 4 examples, as we simplify them, we are going to also ask ourselves what would make the fraction become undefined. So in this part A, B, C, and D that we're going to look at, it says reduce the following expressions to lowest terms. Identify any of the values of the variables that must be excluded to prevent the division by 0, because we do not want that to be the case. So currently part A is written in a very complicated form. So we're going to first simplify this by simplifying the top by doing the distributive property and then adding 2. Fast forwarding, after you do that, you get 2x plus 4 in the numerator. And in the denominator, after I multiply these two binomials and I subtract 1, you are going to get 2x squared plus 5x and then plus 2. This is going to be the part that we're going to actually simplify and factor. So the numerator has a greatest common factor of 2. So we pull out a 2, and then we have left over is an x plus 2. The denominator, we take this 2x squared, pick it up into a 2x and an x, put this plus 2 here with a plus 1, because 1 times 2 is 2. And so now we have this set up. Simplified, right, this is going to cancel this. And so the only thing that remains after that is canceled is 2 over 2x plus 1. Now we have to be able to state what x cannot equal. In other words, what would make the denominator go to 0? So if we look at 2x plus 1, if we set it equal to 0, right, if we said 2x plus 1 equals 0, we find out that x would equal negative 1/2. So that is on our list. Cannot have negative 1/2. And if we take this x plus 2, set it equal to 0, we get x equals negative 2. So we find out the other undefined creating value is going to be negative 2. So our final answer is 2 over 2x plus 1, because these canceled. And then these two numbers are undefined, because they would make our fractions and our expressions in the denominator go to 0. So we do the same thing with letter B. We can factor the numerator, x and an x, and then a minus 3 and a plus 2. The denominator has a greatest common factor of 5x. The remaining factor is x plus 2. That means in the end these two are going to cancel out, right? We'll put that back for now. That makes our final simplified answer to be x minus 3 over 5x. And then we just have to say what would make the fraction undefined. And so that means if we set each one of these equal to 0, 5x equals 0, x plus 2 equals 0, that means x would be 0, and x would be negative 2. So x is not allowed to be 0 or negative 2. And so again, remember those go away, and that allowed us to get our final simplified answer. So looking at letter C, you should recognize the denominator as a difference of squares, so we'll start there. And so it becomes x minus 3 and x plus 3. This says 3 minus x, but we really want an x minus 3, so what we're going to do is we're going to pull out a greatest common factor of a negative 1. That's going to let the signs switch. So again, now this would cancel this one, so we can see what's left over. So the final simplified answer is negative 1 over x plus 3, and all we have to do is address what x is not allowed to equal, and that would be negative 3 or positive 3. One more. We have a greatest common factor here, and so we pull out a 3. This gives us an x minus y, and here we have a factorization. We'll have y and a y, and then a minus x and a minus x. So what you see happening here is the same effect we had to do in letter C. We would really like this x and y to be swapped. So how do we do that? We pull out a negative, and that allows it to become y minus x. And so now we have y minus x and y minus x. Ultimately, this one will cancel here. And so now that reveals what our final simplified answer is going to be, negative 3 and then y minus x in the denominator. We do have to find out what is going to make it undefined. So we set it equal to 0 and find out that if y equals x, that would be bad. So we say that y cannot equal x, and remember these cancel. And so this part in green, that would be our final answer. So that is what we're doing in this lesson. That's the end of the examples and exercises for lesson 22.